Okay, so now we're going to talk about gases and temperature, okay? In particular, volume versus temperature. And if we think back to the nitrogen video that we watched on the periodic table of elements video, where they put the balloon and they had the liquid nitrogen, and you could actually see the balloon decreasing in volume. That should be like an amazing, vivid way of remembering this particular relationship, okay? So when volume versus temperature of a gas are graphed, the plot is linear, okay? So this is meaning that as long as the amount of gas and pressure were constant, okay, that the volume and the relationship between volume and temperature is linear, so it's in a straight line, okay? It is also noticed that when these linear plots were extrapolated, so they were put past what they were actually measured, down to zero volume, all of the lines converged at one point. Okay? So, if we have volume versus temperature for a gas, okay? We're going to plot volume and temperatures in degrees Celsius, okay? And we have this line here. So say this is the data, some data sets that we collected. They all managed to converge at the same point when we extrapolate down to a zero volume, and that is actually negative 273.15 degrees Celsius. Okay? Now, the temperature when the volume of a gas is zero is negative 273.15 degrees Celsius. Now, Lord Kelvin in 1848 suggested that this is the lowest possible temperature, or as we know it today, absolute zero. So he established a new temperature scale, which is called the Kelvin scale in his honor. Okay? So, you need to know the Kelvin actually correlates quite nicely with degrees Celsius. Okay? So, T is used for temperature in degrees Celsius, and capital T is used for temperature in Kelvin. Okay? Now, negative 273.15 degrees Celsius is called absolute zero, or 0 Kelvin. Okay? To go from degrees Celsius to Kelvin, you simply add 273.15. So, for example, here we have 0 is equal to 273.15 Kelvin. 25 degrees is equal to 298.15 Kelvin. 30 degrees negative, okay, is 243.15. So in this case, I would take 273.15 in my calculator and I would minus 30 degrees Celsius. Or if you got a calculator that's going to take negatives, then you can put your negative 30 and add 273.15. And if I've got negative 273.15 degrees Celsius, I'm at 0 Kelvin. Okay? In the next video, we're going to talk about Charles's law.